Hi, I'm Paul Gerrard. Thanks ever so much to Phil and the organisers of PNSQC asking me to do a talk. I was really looking forward to coming to the US this year, but it wasn't to be, obviously. At any rate, here I am. I want to talk about rethinking test automation. Let me start. So business wants IT to move as quickly as possible to allow business to move as quickly as possible to attain their goals, if you like. And so IT and software organizations are now moving more towards continuous development, continuous integration, continuous deployment, continuous delivery, which is the key thing. And if you like, testers have to move with the times and have to move as fast as the organizations building these software products and delivering in a continuous way. Now, continuous testing is clearly dependent on automation in a big way. So test automation or test execution automation is a critical part of that delivery, if you like. But success with test automation is still hard to achieve. Some organizations manage it, but many still struggle. So what I want to do today is really just justify the statement of rethinking test automation and make some suggestions, if you like. I want to pitch what I call a new model for testing. It's not so new, it's a few years old now, but it describes the way we think as testers. And I think this is the way to partly solving our problem with test automation. And then I want to talk about what I'll call future thinking, where really where's test automation going? And I want to drop some big hints about where machine learning and artificial intelligence can come in. There are clear opportunities where this can come to the fore, but also there are product companies who are making progress in this area as well. It's kind of limited and kind of in a niche in some respects, but it's a very big niche. So let me start with a survey that was done at a conference not so long ago. And the first question was like, what tools do you have? And I'm not going to talk about anything other than test execution tools, but like 99%, almost everybody has a test execution tool in place. Beyond that, the questions were like, have you achieved significant benefits? Well, less than 1%. I guess only one hand went up, perhaps in a conference. Do you have shelfware? Yeah, 45%. Did you experience significant problems? 75%. Do you want more tools? 75%. Now, where's the surprise here? Well, the surprise is that really this survey was done in 1997. And I'm sure some of you would think, well, hold on, these numbers look kind of not unreasonable. This survey could have been done yesterday, and the answers would obviously be different. But it's in the right ballpark. We're still having the same challenge of everybody having tools, but few achieving significant benefits. I'm sure it's more than 1%, but it's not 50%. Most companies have difficulty making tools work. So we have this notion of surprise. I want to sort of move on quickly now because it's kind of depressing. But I want to just give a bit of justification to this in that in the 1990s, Dorothy Graham created a thing called the CAST report, Computer-Aided Software Testing Report. And I worked with her on the third and fourth editions towards the end of that decade. And so, my familiarity with tools is kind of been constant for 25 years or so. And so I'm really disappointed that we haven't made progress that we should have done. And this is kind of my justification for saying we need to rethink, because the pressure to get automation working has never been higher. So it's still a challenge after 30-something years, I think. But the questions still apply. So the same questions that existed in the mid-90s and maybe earlier exist now. So, we still don't find it very easy to define precisely what test automation can do for us. I mean, the opportunity is it will automate our tests, But that statement, that language, is simply not good enough. It's too sloppy. We need to be much clearer about what testing is, for a start, and also what tools can do and what tools cannot do. Justifying automation, can automation replace testers? These are the age-old questions that still have present a challenge to us to answer and to understand what the path forward is going to be. And I want to suggest that in the future, tools are going to evolve and probably evolve pretty quickly. And I think we have to rethink how we deal with test automation to answer these questions. I just want to spend a moment on one of the reasons why tools are difficult to succeed with. GUI tools, GUI test automation tools, clearly are very sensitive instruments, let's call it that. And to use an engineering metaphor, they're like surveyor's tools. Now the thing is, if you want to detect whether your structure is out of kilter, you don't need a sensitive tool if your structure is unstable. And in the same way, you don't need tools, and tools will actually get in the way if your software is unstable. And one of the problems that we have is that stability is partly about bugginess, let's say, but it's partly about the rate of change, the number of iterations of increments of software that are being applied to a larger system. These are the things that disturb our test automation. So let me step back and just suggest, well, what is our anti-regression goal? So our goal isn't regression testing. Our goal is to identify and hopefully eliminate unwanted changes to the behavior of software because of wanted change in the behavior of software. And so anti-regression is our primary goal with test automation. And what I want to suggest is to change the target from detecting unwanted changes, unwanted side effects, let's say, to demonstrating functional equivalence. What we're trying to do with our technology is to demonstrate that this version of the software does what it did yesterday or the day before or whenever we last ran our tests. We're not worried so much about whether it works. We're worried about whether it does the same. Now that's a different goal, and I want to just talk about that briefly a little bit later. Now, how do we achieve this? Well, in a nutshell, we have to align the mental model of testers who are writing test automation with the mental model of the requirements that the developers are building against. We have to align our thinking with these people. So we have to collaborate and understand and agree, if you like, what our mental models are. Now, I'm not saying the mental model should be the same, because testers bring independence and therefore bring a different perspective. But we have to understand as testers what the mental model of developers is so we can align our test automation with it. We have to collaborate early. Dare I say, we have to shift left. We have to shift responsibility for testing to the left. Now, I want to talk briefly about the models of testing and test automation in particular that are very widely known. And Brian Marek in 2003, a long time ago, came up with this quadrant, the agile testing quadrants. And it makes sense as it is, but Lisa Crispin and Janet Gregory came up with a more refined version of this to join the dots, if you like. And this model is helpful. There's nothing wrong with it. I'm not going to challenge it in that respect. But again, it's 10 or 12 years old. And the problem that we have is that model now is all pervasive on the internet. When you look for, testing quadrants, you get hundreds of images. So every consultant, every testing services company have their slightly different version, but essentially the same version of that model. It's all pervasive now. Now, another model that Mike Cohn introduced, and again, I think Lisa and Janet made more popular by publishing it more widely through their books, is this test automation pyramid. And the principle is that you automate unit tests, and the volume of unit tests and the volume of test automation is highest at the bottom of the pyramid, and GUI tests should be relatively less well represented, with manual testing being a minority. Now, that's a kind of ideal, but I want to challenge this because to me, this looks exactly like the V model, the right-hand side of the V model. There's nothing new in this except that there's the emphasis on automation is higher at unit test level than at system or acceptance level. Now, the problem we have with the V model is it's part of the waterfall philosophy. It's bounded by staged thinking and, if you like, approaches that Agile reacted against. And yet this is presented as an Agile approach. And this worries me. And this kind of staged thinking won't work in an Agile environment or a continuous environment either. And of course, that pyramid is absolutely everywhere. And it seems to me like for the last 10 years, we've stopped thinking about automation to the degree that these two models, the 4 quadrants and the pyramid, give us all we need to know. But they do not constitute a test strategy. They don't constitute an automation strategy. So the models are still useful, but the thing is, that's page 1 of a book. They give us some insights as to some generalities, if you like, but they don't help us make much progress. And that's my problem with them. Now, again, just to show some ancient history, I did a keynote actually in 1997 at the STAR conference in Orlando about automated testing, past, present and future. This was a rerun for Eurostar the year after. And essentially, I kind of suggested that we need to move from capture replay to design replay. I wouldn't use that language now, but I'd say we want to move from scripted tests to modelled tests. And if, in that respect, we've not made an awful lot of progress, although the major test tool suppliers are all moving towards or have moved towards a more model-based approach to test automation. Now, so that's my justification for having to step back and do some rethinking, let's say. And as a foundation, I want to talk about this idea of a new model for testing, which I kind of came up with about 5 years ago now. And here's my argument that I think we need a new model of testing free from logistics. So if you like, if we are to understand how testing actually works, we have to step back from all the logistical issues and clear our minds, if you like, free our minds. And tools don't think, they support our thinking. So if you like, let's get back to basics and understand how testers think. Now, I'm going to go through this very quickly, I'm afraid, but the foundation of this is to basically take away what I will call logistics. And the way I'll put it is this way for now. For the next few minutes, I'm going to say, I don't care whether you document your tests or not. I don't care whether you use tools or to run tests or you run them manually. I don't care whether you're agile, waterfall, continuous or some other methodology. I don't care what business you're in. I don't care what technology you're in. I don't care whether you're an individual or a managed team. Of course, these things are critically important, but they're not relevant to the testing thought process. That's what I want to suggest. And so if you take all these things away, what's left is, let's say, the pure testing thought process. Now, I haven't time to explain it today, but there's another conference talk. There's a link there if you want to follow it up. If you do a search for my name and new model testing, I'm sure you'll find a video. I've done it many, many times now. But this is the picture here is this concept of testing thinking is split into two major phases: exploration, discovery, you might say, and testing. Running, planning, designing, running tests, whatever. Whether you're exploratory testing or not, I don't care whether you're scripted or not scripted, because the exploration activities are constant, and the test activities where we construct, if you like, controlled experiments to understand the behavior of systems. These things are constant. And all the inquiring, challenging, modeling, informing, and so on, there are 10 of these activities that basically fill in the gaps between this exploration phase and this test phase. And as testers, we iterate between exploration and testing, depending on our understanding of the problem at hand. That is, our understanding of the requirements to be matched, to be tested against. So I'm not going to dwell on the picture other than to say it's a model of thought processes. It's not a process to follow. So the various activities, inquiring on the top left, this reflects how we gather information, whether we read or interview or listen to people or just have conversations. However we get information from our source of knowledge, that little activity, it doesn't have inputs and outputs and a procedure and entry criteria and exit criteria and stuff like that. It's just a mode of thought, and we use our brains to inquire and to gather information. So it's a mode of thinking, not a process to be followed rigorously. Now, in the context of this, I want to suggest that the term test automation misleads, because people who don't know anything about testing think that tools do all of this stuff, and clearly they don't. And I want to just highlight where I think test execution tools fit, which is this applying activity towards the end. And as part of the applying, there's this concept of checking, which is popular now. Well, checking fits inside that applying, and checking is only part of the application of a test, because the application of a test includes setup, entering data, checking results, maybe logging anomalies. And so what tools do for us is a fraction of what testers actually do and have to think about. And that's the point. And I use this model now to explain how automation fits into the job we call testing. Now, I want to just spend a couple of minutes on this concept of the left and the right. And the left is about exploration, gathering information, building mental models, which you might write down, but mental models are good enough. And then the right-hand side is where we use those mental models to inform our test design, to apply tests, interpret outcomes, and so on and so forth. To the left and the right are the exploration and the testing. And if you like, the thinking on the left contributes to the evaluation, interpretation of requirements themselves. Okay, so think of the three amigos kind of activities where the developer, the product owner or user or business analyst and the tester work together. So the opportunity to flush out muddled requirements is on the left. And so the models that we derive, having iterated and challenged those models and improvement, it's the models on the left are the blueprints for the tests on the right and the automation on the right. And so automation won't work if the thinking on the left is not in place. We don't have clear understanding of what the system should do and how it's going to operate. If we apply automation to muddled, loose requirements, we're in big trouble. And if we aren't involved on the left, we aren't in a good position to test at all, with or without tools. So the tools challenge, I want to suggest, is not test execution, because test execution engines are commodities. There's open source versions of these products and there are proprietary versions, but I think you'll find the vendors are beginning to move towards where the real value is to testers, which is in test design, selection, test data management and frameworks. And I'll talk about these things in a little bit, in a moment. So I want to suggest that test automation is not a test execution problem. It's a modeling problem. So we need to shift our testing thinking to the left. We need to model to improve requirements to help developers, users, and ourselves as testers to agree and have consensus on the true requirement, if you like, and to share our understanding through modeling. And so by so doing, we can eliminate mistakes in code, but also mistakes in automation, in test automation. Now, I want to move on to kind of the social aspects of this almost, in that one of the challenges that testers have is a lot of testers believe that tools cannot do what testers do. And I'm absolutely on board with that one. But it's a more subtle idea than that. It's no one believes that test tools can do everything that testers do. Of course not. But what the jobs that test tools do, they can do very well. But we have to understand, the notion of modelling in order to create good test automation. And we could say, well, there are 4 areas, and this is just one way of slicing it up. There are developer tests that typically are automated. There are checks that can be done through programming interfaces, APIs, if you like, and even run end to end as strings of tests. And then there's compatibility and configuration testing across platforms. Sure, these are all things that can be done by tools. And then there are tests that can only be done by humans. And the challenge we have as individuals, as testers, is we have to delegate the things that can be done by tools to tools. And I think there's a notion that a lack of trust is the only way I can put it, and that we don't trust tools to do everything, if that's the right word to use. So one of the challenges we have is we have to think and believe that tools can do more than we currently get them to do, if you like. So this idea of shifting left and delegating responsibility is part of this shift left movement that's happening, where we are asking developers to take more responsibility, to use technology to test. But as testers, we give them more support. We might coach them, mentor them, that kind of thing. And we're reducing the dependence on late automated end-to-end or UI tests. Although we'll always have UI tests because it is a final confirmation that we can string transactions together in a user journey, if you like. But the challenge we have is we have to trust developers to do better testing, and we have to trust test automation. And this is kind of a personal challenge as well as an organizational challenge, I want to suggest. So, okay, with that background, I want to say, right, these are the things I want tools to do for me in the future. So I'm going to sort of set some kind of challenges and then say, this is what I want tools to do to solve these problems. So the first one is regression testing, front and center. And the challenge we have is there are tools which can do impact analysis of changes in code, but by and large, we're working in heterogeneous, mixed environments. So there's no one tool that can tell us the impact. And systems being built from components aren't one monolithic piece of code. So we have no reliable means of impact analysing proposed changes in code. So as a consequence, we rely and we over-rely on testing as an anti-regression measure. It's like our only tool in the golf bag, if you like, our only club. So what we tend to do is we take some of the tests, maybe all of the tests, but usually it's a subset of the tests we use to prove functionality to be our regression test pack. This is the traditional approach. The problem is tests that we use to find bugs very often have a lot of duplication across themselves. They don't give us enough coverage to demonstrate what I will call functional equivalence. If you like, the metaphor I use nowadays is like what we're trying to do is we have the mold, which is the tests, and then we have the cast, which is the system. And we want to know whether the system will fit the tests that we had yesterday. We want to know that the moulding will fit the mould still, and nothing has changed in the meantime. We're looking for equivalence, and the discrepancies will come out, of course. But what we're really trying to do is demonstrate that the system does what it did yesterday, the day before, and the day before that. Now, this is a different goal from finding bugs. We don't care what the software does. We care that it does the same as it did yesterday, the last time we ran our tests. So right now, as an optimal set of tests for our regression test pack, we guess. We don't have the information to hand, and we rely on experience, intuition, and a bit of guesswork. So what we need tools to do, is we need tools to identify features and end-to-end tests and data values that trigger failures. We need to understand the history of failure in our tests, because tests that have found failures in the past are likely to find failures in the future, or more likely, should I say. We need to identify patterns of changes and locations that triggered failures in the past. So we need to understand the patterns of data that caused failures in production and use that as part of our input to understand where we should test, what selected paths and what test data is representative of these failure-prone features. We need to understand from our tools which tests have the best chance of causing regression failures. Now, this is an impossible task to do manually, and this is where machine learning and AI, if we have the data and the models, there's a good chance we can get more reliable recommendations than the guesswork that we rely on right now. The second phase is, if you like, this depends on what I'll call integrated systems intelligence, let's say, very grand sounding term. Right now, very, very few companies have any kind of integration, if you like, between production logging, production data, and systems, the structure of the systems themselves. We can't map production logs to actual transactions except at a transaction level. We can't map item by item data to fields that were entered in a system. So as a consequence, we manage test data rather poorly, rather crudely, and we just tend to take subsets of data and try and reuse that most often. And the challenge we have is our defect history isn't linked to our production logging experience, if you like. So we can't use our production data test and defect history to steer our choices of which tests we run. We can't use that data to identify patterns or improve our process as well. So part of this game is understanding, yes, we can improve the software, but if we can identify the patterns of behavior that cause problems in our production systems, maybe this is where machine learning can come in. So for this to happen, machine learning needs models that integrate the information across these different silos. So what I want tools to do is to recognize process, production, defect, history, data relationships. What I want to do is to bring all this data together, and this will entail potentially some automated recording, but potentially we have to just do the legwork to create models that map these different data sets so we can link them together. I want tools to provide visualizations of patterns that reflect failure and the causes of failure. Now, again, we have to be careful about cause and effect, but we are in the game of looking for these patterns, and tools can help us to recognize these patterns and give us insights. We don't have to follow them blindly, but they might expose patterns that we were never aware of. We want tools to provide guidance on practices and change patterns that make failure more likely. So we want to know what has caused us problems in the past so that we don't repeat those mistakes in the future. The third aspect is a major driver in larger installations, certainly packaged installations, is companies are reluctant to upgrade their systems because of the cost of testing and the risk of failure. So we need tests that adequately demonstrate this phrase, functional equivalence. And we need to do this continuously and with little human intervention. Now, if you think about it, and we all have done, but regression testing should in principle be dead easy. All we're trying to do is to demonstrate that some feature or some system behaves the same way as it did the last time we ran a test. Now, the principle of it is very simple, and the data is available in our systems to tell us how the system did behave, and therefore we can use that production data in principle to drive through tests to demonstrate it still behaves the same way. The data is there, it's just that we don't have a mechanism to bring it into our test environment and drive our regression testing. So the things we need here is we need to understand the highest risk areas of change. We need our tools to tell us this. We need to generate tests that are capable of demonstrating functional equivalence, that maximize the areas of coverage of criticality. And this, by the same token, if we have a test logs and history, we know which tests run faster than others. That is, the shorter duration. So we need to pick the tests that are more efficient and will give us the answers sooner rather than later. Now, in this way, we can create tests that are more resilient to change because we're driving it by the data in production more than our guesstimates of things that might work through our experience, if you like, or our intuition. And we need to prioritize tests according to their effectiveness and efficiency because we haven't got the time to run every test. So we have to have a mechanism for prioritization. And this is part of what machine learning and AI promise to do for us. So these are the things I want to suggest are on my shopping list. And I can tell you that more than half of them are available in products in some contexts. So the progress in this area is primarily in, if you like, enterprise resource planning, SAP and Siebel and all those products, banking, and there are other package areas where these models exist and can be exploited to feed machine learning products to give us insight, certainly to do pattern matching. The challenge we have here is that what works for a package is where you have this scalable and economics of scale, where you can reuse the same models on the same package in many installations. So from the perspective of the tool vendor, this is an economic way and a viable business opportunity for them. That hasn't been the case in the past. Now, for a more general tool, I think it's going to take more time to move in this direction. But I think time will tell. It might be 10 years or more before we see products that are so clever. So I want to close, and if we have the products that support test execution, test data selection, frameworks, which I haven't talked about, but frameworks are critical to every implementation of test automation. Testers have to move away from this passivity of being the guys who work at the end, who are the victims at the end, the servant to developers at the end, more towards active collaboration. We need to challenge and refine requirements and use modeling to help us to do that. So we can map changes to business outcomes, if you like. And we should act more like a navigator or a pathfinder in projects rather than a servant, if that makes sense. And in principle, what we're going to do is we're going to leverage our thinking. That is, we think deeply about testing, but we don't expose that thinking in any way other than to have conversations. We don't expose our models. And I think we have to use that thinking to create mental models that we share and agree with our developers, BAs, product owners, whoever, so that we have a better insight into the requirement, but also a model that will be our blueprint for test automation. And I'm sure that will give us a big step forward, but it's going to take time to get there. Thank you.